Welcome back to Science Modernizers. Welcome back to this video. In today's video, we are going to continue with the topic bearings, and the lesson of today will be how to draw bearings greater than or equal to 180 degrees. Okay, so we are going to begin the lesson with our objectives. So at the end of this lesson, you who is studying should be able to draw bearings greater than or equal to 180 degrees. So let's begin with a real life situation. Okay, it says a ship is sailing towards a destination that is located at a bearing of 250 degrees from its current position. As a navigator, how can you help your captain draw this bearing on a chart? So we'll come back to this, picture the problem, and see what you can try to think about it and see what you can do. We'll come back to it at the end of this video. So let's take an activity. So we'll have to follow the following steps and see what and follow the steps keenly, reproducing them on a piece of paper. Now before you should have a blank sheet of paper, your pencil and your protractor. Now the first instruction says mark a point P on a blank page. The second says draw a north line from P. The third says using a protractor measure 330 degrees from the north line. Call the point A. Now to do this, subtract 330 degrees from 360 degrees and measure the result in an anti-clockwise direction. So why is this given? Because the protractor has values from 0 to 180 degrees. So you cannot have 330 degrees on your protractor. So that is a methodology or a method to have the 330 degrees in or measuring in the reverse sense. Now the fourth is link A to P with a line segment. And finally, what name is given to the angle between the north line and the line AP? So now you can pause the video, do the activity and check the correction and see where you have gone wrong. Okay, so let's get started with the solution. So the first point says mark a point P on a blank page. So that is my own blank page. The next is to draw a line from P. So we draw a north line from P. So I'll call that my north line N. Now using a protractor, we are going to measure 330 degrees from the north line and we call that point A. So what we do here is, since we cannot measure 330 degrees from our protractor, so we are going to measure 360 minus 330 degrees. So this will give us 30 degrees. So we are measuring 30 degrees from the north line in an anti-clockwise direction. Okay, so let's do that. So I have to place my protractor. You see the values inside are going in an anti-clockwise manner. They're increasing in an anti-clockwise manner. So we are going to use the values inside, that is the blue values. So we are going to start. This is the anti-clockwise direction. But remember that that is not the bearing. In the previous video, we saw that bearings are measured from the in the clockwise direction from the north line. So here we are going. So let's take our 30 degrees anti-clockwise. Anti-clockwise. So we have 10, 0, 10, 20, 30. So we mark our point of interest and we call it A. Now we carefully remove our protractor and we follow the next step. Link A to P with a line segment. So we'll link A to P with a line segment. What name is given to the angle between the north line and the line AP? So we have seen that the measure of this angle is 30 degrees, which is not the bearing because it was measured in the anti-clockwise sense. But our bearing is to be measured from the north line as shown. So this blue curve is our bearing. So all of this is our bearing. So we have successfully drawn 330 degrees. So that is how we draw bearings that are greater than 180 degrees. So this fact comes from this comes from the fact that in a complete revolution, or the angle made in a complete revolution, is equivalent to 360 degrees. Now, since our protractor cannot measure this, we just have to take the total angle minus this, and it gives us a possible angle that our protractor can measure. But what you are measuring is not the bearing. The bearing is from the north line. Okay, so that is it about this learning activity. So let's go to the summary. So the fifth set, what name is given to that? So the angle from N to AP is the bearing of A from P, and hence the bearing of A from P is 330 degrees. So we have successfully drawn a bearing of 330 degrees. So now let's move to our summary. So to draw bearings greater than 180 degrees, we subtract the bearing from 360 degrees, then draw the result in a reverse manner, in bracket, the anti-clockwise. Remember, for the bearings, or to draw bearings, we always leave from the north line in a clockwise direction. But since values greater than 180 degrees cannot be found on our protractor, we subtract the value from 360 degrees and we measure it anti-clockwise. Then the corresponding clockwise angle is what we call the bearing. So let's take our application exercises. So draw the following bearings: A, 290 degrees, B, 050 degrees, C, 320 degrees. So we are going to begin with the first, A, 290 degrees. So we are going to take our arbitrary point, we'll call it a certain P. Now from P, what we do is we draw a north line. So we'll call that my north line. Now what we have to do is we have to measure 290 degrees. But 290 degrees is not possible on the protractor. So what do? We take 360 minus 290 degrees. So the equivalent anti-clockwise angle will simply be 360 minus 290, which gives us 70 degrees. So you now measure 70 degrees with your protractor and you have a point which will be somewhere around here. So you can do the measurement and we can call that point A. The next thing we do is we link the point P to A, and then we measure this bearing. So this gives us 290 degrees. So that is our bearing, and that is how it's done. The first case, or the second, that was 050 degrees, is a case that we saw in the previous video. So there it's anti-clockwise. Sorry, there the angle is between 0 and 180 degrees. So the procedures remains the same. So we have our point P, we draw our north line, we can call that north line N, then we measure 50 degrees, which will be somewhere around there. You can use your protractor, we can call that point A, then we link. Since the angle is between, this is our bearing, so 50 degrees. Now for the C, 320 degrees, we start by calculating the equivalent anti-clockwise angle. That will be 360 degrees minus 320 degrees, and that will give us 40 degrees. So we fix our point P, we draw our north line, call it N, then we measure 40 degrees going this way. So we have 40, can be somewhere here. We can call that point anything, maybe B. Then we link P to B, and then this is our bearing. That's 320 degrees. That's how it's done. So the D is 180 degrees. So D, which is 180, is just a straight bearing. So here we have P, we have our north line. If you place your protractor in any of the senses, you will always see, if I extend this line by its projection, then 180 degrees will just be on the line, and so our bearing will just be that angle, 180 degrees. So you can do these things keenly with your protractors. Okay. Let's take another set of exercises. We are given this diagram and we are asked to find the bearing of A from B. So this point is the point B. So the bearing of A from B will be the equivalent clockwise measurement of the angle from our north line to A. But we saw previously that from this point right up to this point, that is a straight angle which is equivalent to 180 degrees. So it means this bearing will simply be equal to the angle 180 degrees plus 25 degrees. So we are going to have 180 degrees plus 25 degrees, and this will give us a total of 205 degrees. So that is the bearing of A from B. Okay. The next, we have to find the bearing of A from P. The bearing of A from P is the measurement in the clockwise sense. But remember, we said that the angle or the total angle in one revolution gives us 360 degrees. So this means if we call our bearing a certain x, then x plus 55 degrees should give us 360 degrees. So this will mean that our x will be 360 degrees minus 55 degrees. So this will give us the value of x to be 305 degrees. So it means that the bearing of A from P is 305 degrees. And that is how it is done. If you have any difficulty, you drop your questions in the comment section and it shall be attended to. Now, going back to the real life situation, it said a ship is sailing towards a destination that is located at a bearing of 250 degrees from its current position. As a navigator, how can you help your captain draw this bearing on a chart? So we are going to do that and you verify if what you did was correct. So you see, our point or our current position is our P, and in our case it is a ship. So let's keep our ship. The next thing we do is we draw the north line from our current position. So that is our north line N. What's the next thing we do? we have to measure the given bearing, but since it is more than 180 degrees, we have to calculate the equivalent clockwise angle, which will be 360 degrees minus 250 degrees, and this will give us 110 degrees. So it means we are going to place our protractor and measure 110 degrees in the anti-clockwise sense. So the values inside are the goes in the is increasing in the anti-clockwise direction. So we are going to use the blue values. So the first is 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110 clockwise, and we mark the point. So from there we can remove our protractor and then we link from the ship to our destination. That destination can be home, can be anywhere, it can be the seaport, anywhere. Then we have that bearing, which is the total angle measured, which is this red line, should now give us 250 degrees. And that brings us to the end. So an assignment will be, draw the following bearings: A 325, B 127, C 273, and D 274 degrees. So in our next lesson, we are going to see problems involving bearings. Thanks for watching. Do not forget to like, share, and subscribe. See you in the next video.